Hey guys, this is the Chem 1 lecture on salt hydrolysis. Let's go ahead and break down these two words. Salt is an ionic compound containing a metal and a nonmetal that is formed when an acid reacts with a base. Hydrolysis is using water to pull apart bonds. And so basically what that means is that when we put a salt into water, the salt's going to break up into its anions and cations, and it's going to react with the water, and it will, based on the salt, will make the solution acidic, basic, or neutral. So the goal of today is we're kind of working backwards. If we give you a salt, we want you to predict when this goes in water, what will the pH be, acidic, neutral, or basic? Okay, before we jump into predicting pHs, let's go back memory lane of Unit 10 and write a balanced equation for the reaction of nitric acid and potassium hydroxide. Okay, so nitric acid, we know acids have a hydrogen ion. There's no hydro. Ic came from 8. That would be nitrate. And so our acid is HNO3. Potassium hydroxide, potassium and hydroxide, that's a 1-to-1 ratio. So here are our reactants. And then this is a simple double replacement. Our two cations will switch places. So H is going to go where K is and create water. I'm going to leave it as HOH just for balancing purposes. You can write H2O, either one works. And then potassium is going to be with NO3, and I already know that that's a 1-to-1 ratio, +1, -1. There's no need to swap and drop. And then so the last thing is just check out for balancing. And I think this one is already balanced. 1 hydrogen, 1 single hydrogen, 1 NO3, 1 NO3, 1 potassium, 1 potassium, 1 OH, 1 OH. So that's just, you don't even have to write anything, or you could put ones in, reassuring that you balanced it. Okay, let's do one more neutralization reaction. So we're reacting an acid and a base. Sulfurous acid is H2SO3. And iron 3 hydroxide is Fe(OH3). The hydrogen and the iron are going to switch places, so we always make water. And then iron will react with sulfite. Iron's a +2 charge. No, iron's a +3 charge. Sulfite is a -2. Sorry, I'm like trying to do multiple things. It's Fe2SO3 3. So iron was +3. Sulfite was SO3 -2. And so that's probably y'all's biggest mistake when you're writing, also in Unit 10, is rechecking your charges when you make a new compound. And then lastly, let's go ahead and balance. I have 2 single hydrogens. I have 1 single hydrogen. Okay, I'm tempted to put a 2 there, but then I see I have 1 OH and I have 3 OH. So I'm just going to take this to 6. And I can make that 2. 2 times 3 is 6 hydroxides, 6 hydroxides. 6 single hydrogens. I'll put 3 times 2, 6 single hydrogens. I have 3 sulfites. I already have 3 sulfites on the other side. 2 irons, 2 irons. So 3, 2, 6, 1 would be my balancing coefficients. Okay, I'm going to use sodium chloride again as an example of a salt, metal and a nonmetal. The cation is always your positively charged ion in the front, and your anion is in the back. The cation of a salt came from the parent base. And we're going to assume all the bases are hydroxide based. And then the anion, the back part of the salt, we're assuming comes from the parent acid. So in this case, Cl came from hydrochloric acid. This process of kind of pulling the salt back to its origins of the acid and the base is super helpful when we later on start to predict the pH. So the way to predict the pH of a salt when placed in water is you take it back to the origins. You take it back to the parent acid and the parent base, and you have to remember back from lesson 1 in this unit, what is the rules for strong bases and what are the rules for strong acids. And so once you pull your salt back to how it was formed and you identify what type of acid and base it is, when you have a weak acid and a strong base, then when that salt hits water, it's going to favor whatever is strong. And so this would be we would predict a basic solution. Because once this reforms, this weak acid's only partially ionized, so they're going to stay as a molecule, but strong bases 100% ionized. And so that's going to create hydroxides in your solution, making it a basic solution. When you have the combination of a strong acid, weak base, then the strong's going to favor, and the solution would be acidic. So once again, when things reform in the water, this weak base is going to, this is the weak base, it's going to stay together, but the strong acid's going to ionize, and that hydrogen's going to form hydronium, creating an acidic solution. Well, what happens when you have a strong base and strong acid? Well, then it's going to be a tie. It's going to be a neutral pH, so pH around 7. And then what happens if they're both weak acid and weak base? This becomes a little more complicated, and we're not going to go in depth in this class. Okay, so working through this chart, we're going to give you a salt, and then it's giving you space to write out the parent acid, parent base, as well as tell you, is it a strong acid or a weak acid, and then determine the type of solution. Before we jump in, let's just do quick memory on how do you know if a substance is a strong acid, and then how do you classify what is a strong base? Let's see if you remember. So strong acids, there's 3 binary acids, the ibrine clay, hydroiodic, hydrobromic, hydrochloric acid, or any acid that has 2 more oxygens than hydrogens. And then a strong base is any base that has an alkali metal in it, or strontium and barium. It formed a little B on your periodic table. Okay, so with that reviewed, let's take on sodium chloride as our first salt. And so if you remember, you cut the salt in half. So the acid is always coming from the anion, which is the back part of your salt. So that would be HCl. And we know something you'll need to be careful of with nomenclature is just check your charges. So HCl is a 1-to-1 ratio. And then Na is going to be with hydroxide, sodium hydroxide, also +1, -1. We are assuming that all the parent bases are hydroxides. Okay, and then go back to our rules. Hydrochloric acid is a strong acid, and sodium hydroxide, sodium is an alkali metal, group 1 on the periodic table, so that's a strong base. So if they're equal strength, both strong, then this would form a neutral solution, a pH right around 7. Okay, let's try another example. This is ammonium nitrate. So the NO3 is coming from the acid. That's also a +1, -1 charge. NH4, ammonium hydroxide, also +1, -1, using the back of your periodic table. Okay, HNO3, is it a weak or strong acid? Well, we have oxygens. There's 3 oxygens, 1 hydrogen. So there's 2 or more oxygens, so it's a strong acid. Ammonium hydroxide is not an alkali metal or strontium or barium, so this is a weak base. And so the type of solution will always favor what is strong. And so because we have a strong acid, we would predict this to be an acidic solution with a pH less than 7. Okay, let's try a third example, barium phosphate. So the acid is PO4, so that is phosphoric acid, H3PO4. So hydrogen is +1, phosphate is -3, so that's why we got H3PO4. And then barium carries a +2 charge, hydroxide's -1, so we'll have to balance. Okay, and then identify phosphoric acid is a weak acid. There's not 2 or more oxygens than hydrogens. Barium hydroxide is one of those metals considered a strong base. So because the base is the stronger one, we would predict a basic solution, a pH greater than 7. It's supposed to be a math symbol, greater than 7. Okay, let's do one more example. If you had the salt copper 2 sulfate, what type of solution would we predict? So SO4, that's coming from H2SO4. Once again, just checking your charges. And then copper, you would need to have dialed into your nomenclature days. Copper is an unpredictable charge, so you work backwards. We know sulfate's -2, copper must be +2. So that would result with CuOH2 using your parentheses. And then identify your strengths. So sulfuric acid is a strong acid due to 2 more oxygens than hydrogens. And copper hydroxide is a weak base. Copper is not an alkali metal or strontium or barium. And so this would favor the acidic range. Okay, this concludes this salt hydrolysis lecture. If you were in class, you would go back to lab. If you missed class, make sure you go to the website for your makeup lab. Thanks for listening.